Hello guys, we are going to look at logarithm lesson 1. Now when you look at what we have over here, a to the power b is equal to c. This is an exponential function which we have already learned. Okay, now when you look at it, a is equal to the base, b is the exponent, and c is the number. Logarithm is in the form log, then you have the base term, then we have the number, and it's equal to the exponent. So it means exponential functions can be expressed in the form of log. In the form of log, we are going to have log with the base, number is equal to exponent. And so taking the exponential function that I've already given over here, a to the power b is equal to c. Taking this into consideration, it means we can transform this into logarithm. Therefore, we are going to have a to the power b is equal to c, which will translate into log. Now, when we look at the exponential function, a is the base, so it will give us log base a. Then the number is c, which will also be written over here in place of the number as we have it over here. Then finally, that will be equal to the exponent, which is b. Or if you have log ac equals b, you can transform it into exponential function. What is the relationship between this variable a, b, and c? The relationship is very simple. A to the power b must be equal to the number that we have here, or the variable, which is c. Okay, so that is the relationship between them. Now with this established, then it will be very easy to evaluate what we have over here. Question 1. Evaluate I log base 2 16 and I log base 3 27. Let's take the first one, I. Log base 2 16. So log base 2 16. We don't know what log base 2 16 is. So what do? We represent it by a variable. Let's say x. Now, if log base 2 16 is equal to x, then let's establish the relationship between these numbers as we have them over here. 2 to the power x is equal to 16. And so we have transformed the log function into exponential function. And with this exponential function, then it means we have to break 16 using the base of 2. And so we are going to have 2 to the power x, and that will be equal to 2 to the power 4, because 16 is 2 to the power 4. Therefore, our x will be equal to 4. Therefore, our log base 2 16 will be equal to 4. That is I. Now let's go to II. II, we have log base 3 27. Let's say it is equal to x as well. And so this means we are going to have 3 to the power x is equal to 27. 3 to the power x is equal to 27. We therefore need to break our 27 using base 3. And so this is going to give us 3 to the power s is equal to 3 to the power 3. Therefore, our x is equal to 3. So it means our log base 3 27 is equal to 3. Now let's go to the next thing over here. The next thing that we have over here is to evaluate this. Okay, to evaluate I log base 3, 3 to the power 5, I log base 5, 5 to the power 2. So let's take the first one, I log base 3, 3 to the power 5. We are going to equate this to x. And so I can say, therefore, 3 to the power x will be equal to 3 to the power 5. This one, we need not break this one further because they are all of the base 3. And so our x will be equal to 5. This means log base 3, 3 to the power 5 is equal to 5. Let's go for the second one, I. Now when we take I, that is log base 5, 5 to the power 2. Log base 5, 5 to the power 2. This is going to give us our x. So let's say this implies 5 to the power s is equal to 5 to the power 2. Therefore, our x is equal to 2. Okay, so this implies our log base 5, 5 to the power 2 is equal to 2. This leaves us with a conclusion, and the conclusion is that if we have log base a to the power x, then it must be equal to x. This is an important conclusion we need to take note of. An important conclusion, log base a to the power s must be equal to x. Now let's look at the next question. The next question, evaluate I log base 4 1 over 64. Then I log base 6 1 over 36. How do we evaluate this? Let me take I over here log base 4 1 over 64. We don't know what it is, so let me represent it by is equal to x. And so this implies that our 4 to the power x is equal to 1 over 64. Okay, notes. If we have 1 over a to the power b, it is equal to a to the power negative b. And that is what we are coming to use over here. Okay, so our 4x will be equal to 1. Then we break 64 using base 4. 64 using base 4 is 4 to the power 3. And so we are going to have 4 to the power x is equal to 4 to the power negative 3. Okay, so therefore we are going to have our s is equal to negative 3 log 4 1 over 64, therefore will be equal to negative 3. Then I log 6 1 over 36. Log 6 1 over log base 6 1 over 36. So what are we going to get? Here I'm going to use another method in solving this. So this is going to give us log base 6. Log base 6. I am going to break this 1 over 36 using the base of 6 will give me 6 to the power 2. 6 to the power 2. Okay, so this is going to give me log base 6, log base 6, 6 to the power negative 2. Okay, earlier we established that if the base and this number are equal, then we get the exponent. Okay, so this is going to give us our negative, this is going to give us negative 2. Okay, that will give us negative 2. Okay, so therefore our base 6, log base 6, 1 over 36 will be equal to negative 2. The next type we are considering is to evaluate log base 10 10, where the base and the number are equal, where the base and the number are equal. So let's take the first one. I log base 10 10. Okay, since we are breaking it to the same base, let me say let this be equal to x, then we are going to have 10 to the power x is equal to 10. And we know any number to the power 1 will give us the same number. So this means that 10 to the power x is equal to 10 to the power 1. 10 to the power 1. Therefore, our x is equal to 1. Log base 10, 10 will be equal to 1. I log base 3, 3 is equal to log base 3, 3 to the power 1. Okay, and if the base and the number here are equal, then we get the exponent, which is 1. Okay, so this leaves us with a very simple conclusion, and the conclusion is that log base a is equal to 1. A very important conclusion we need to take note of. Now let's go to the next one. The next one we have over here, simplify I log base 3 1 and I log base 6 1. So how do we simply do this? Our I over here is going to be log base 3 1 is equal to x. Log base 3 1 is equal to x. This implies our 3 to the power x is equal to 1. Okay, so we need to express this number over here, 1, in terms of what? A base of what? 3. And so this is going to give us 3 to the power s is equal to 3 to the power 0. Therefore, our x over here will be equal to 0, which implies that our log base 3 1 is equal to 0. The second one over here, I log base 6 1. Okay, so this one we will express it as log base 6. I am going to express this one over here using 6 as the base, and that is going to give me 6 to the power 0. Okay, so 6 to the power 0. So if this and this are the same, then it means our exponent will be our answer, and that will be equal to 0. This implies log base 6 1 will be equal to 0. Another important conclusion over here, log base a 1 is always equal to 0. So if you have the base and you just have 1 over here, then the final answer is going to be 1. Now let's look at this one over here. Evaluate log base 2 8 root 2, and that is going to give us log base 2 8 root 2 is equal to x. We don't know, so let's find our x. This is going to give us 2 to the power s is equal to 8 root 2. Okay, so we are going to break this to the base of 2, and we are going to have 2 to the power x, and that will be equal to 2 to the power 3, because 8 is 2 to the power 3. Root means to the power, root of 2 means 2 to the power half. 2 to the power half. Therefore, 2 to the power x will be equal to, this is indices. When the bases are the same and you are multiplying, you add the exponents, and that is going to give us 2 to the power 3 and half. Therefore, our x will be equal to 3 and a half. Okay, so log base 2, 8 root 2 will be equal to 3 and a half. In conclusion, log base a, b is equal to c, transform into an exponential equation a to the power c equals b. Log base a to the power x is equal to x, where the base and the number here is equal, then you get the exponent as the answer. Log base a is equal to 1, then log base a1 is equal to 0. Log base a1 is equal to 0. Now let's quickly answer the following questions over here. The first one, evaluate the following. Log base 3, 27 root 3. Log base 2, 32. Log base 5, 1 over 25. Then IV, log base 7, 1 over 49. Then V, log base 4, 8. Log base 4, 8. Pause the video and solve them and check whether your answers are correct. Just pause the video, work them out, and check whether your answers are correct. If you have solved them well, then your solution should look like this. Your solution should look like this. Okay, thank you very much for your attention.